I love solving these, and there's a lot of different ways. Like if you were to look up or scan this on an app or something, it might show you a different way than what I'm going to show you. The easiest thing I can tell you to do if you're solving a rational equation. So rational equation just means you've got fractions and somewhere your variable is going to be in a denominator in one of the fractions that's in the equation. The easiest thing I can ever tell you how to do to solve these problems is just make all the denominators match. So like make all the denominators a common denominator, and then I'll show you what you can do. Okay, so in this very first problem, I have 6 over a, 4/9, and then 2 over 9a. What would be a common denominator between all three of those? 9a. Okay, so I'm just going to put in what I need, right? So this guy has an a, so I would need to multiply top and bottom by 9, which is really multiplying by 1, so we're not changing the value of that term, we're just manipulating it for our purposes. And then this guy has a 9 but doesn't have an a, so I would need an a top and bottom of that fraction kind of in the middle there. And the deal is, if you add fractions together, right, if they have a common denominator, that denominator would just stay the same. If you make all the denominators the same, you can literally just cross the bottom of the problem out and just work on the numerator in terms of your equation. And not specifically for this problem, but for some problems it would save you from doing a quadratic or something like that, and you just have like an equation that just had one variable. So this, I promise, this is the easiest way I have ever learned to do this. You actually have to simplify the top though. So when I'm multiplying here by 9 over 9, I do 9 times 6 on the top, so that would be 54. And then we'd have plus the 4a equals 2. And that's way easier to solve than what we were presented with initially in that equation. So I'm just going to subtract 54 here real quick, bless you. We're going to get 4a equals, what, negative 52? And I'm pretty sure that that is negative 13. Now, when you guys work on these equations, you do have a potential for extraneous solutions. And that would be if you get something that would make your denominator 0. So you don't have to write this or anything, but just for this problem, I just want to think about what number would cause me a problem in the denominator if I plugged it in for a in this problem. Like in the original problem, what number would I plug in for a that would make a denominator 0? 0, right? Okay, so I'm just going to jot this down for myself just really quick. And you will get this on a couple of the equations today. If your answer is what we would call a restriction for the questions we've been working on, then it's possible you will have no solution for a couple of these equations today. So just keep that in mind. So we got negative 13, that's not a problem. So that should work. All right, what would you use as the common denominator between 2/3, 9/4, and 5 over y? 12y. All right, so we're just going to put in what we need, and then we can cross our denominators out. All right, so what would I need top and bottom of the first fraction? Times 4. Anything else? You also need the y. So there we go. Okay, what would we need in the middle? 3y. All right, and then what would you need on the last one? 12. Okay. Now, I didn't write it all out or anything like that, but all those denominators, if we simplified, would be 12y. So I'm just gonna, don't even mess with it. We're just gonna work on the top. Okay, you can multiply all of these. So 4y times 2 would just become 8y. 9 times 3y would be 27y. And 5 times 12 is 60. And this is where you might want a calculator. I don't think this is a nice number. So if I add 8 and 27, what do we get? 35y equals 60. So my answer is not going to be a nice number here. I'm going to divide by 35. And I'm going to cheat and grab my calculator and do my favorite button that you guys know, my math, enter. 60 divided by 35 is going to reduce to 12/7. And as long as it's not your problem number here, it's very similar to the question we just did. Your y value could not be 0. That would be the only restriction we'd have if we looked at any of those fractions. That's not what we got, so we're good to go, and that should be our answer. Does anybody have a question? Okay, now these get weirder as they go, so I'm going to give you some different tips for maybe what would make the problem easier to work with. If you have something like I have here, y plus 4 over y equals -5, what I would still tell you to do is let's get a common denominator between each of these, but I don't have them all as fractions. So I'm just going to take the y, I'm going to write it over 1, and I'm going to keep the 4 over y in the middle, and I'm also going to take that -5 and put it over 1. Okay, what would a common denominator between all three of these be? Y. All right, so all you're going to need, top and bottom here, y. I don't need anything in the middle, and top and bottom here, y. If I make all those denominators match, it forces the numerators to be equal. So we just cross this right on out. Now, in this one, and some of these you will, I'm going to get a quadratic on this. So I'm going to get y squared, because I'm doing y times y, plus 4 equals -5y. What would you do from there? I got y squared plus 4 equals -5y. What do I do? Yeah. All right, let's just move. Just set it equal to 0. You got a quadratic. Sorry. If you get one, I promise it'll be factorable. But we got to move that to set it equal to 0. Now, I could use the quadratic formula, or I could factor. Can anybody factor y squared plus 5y plus 4? Eli, what do you think? That's y plus 4, y plus 1. Okay, now, what are my actual answers then to the equation? Oh, yes, you're totally right. -4. -1. Now, if you look at the original problem, the only thing that we ever had in the denominator was just a plain y, so the only answer that wouldn't work here would be if we were to have gotten 0, which we didn't, so this question actually has two answers, the -4 and the -1. Okay, is anybody having a question at the moment? All right, now, if you have something like this, there's no variable in the denominator, right? If you have something like this, I have no variable in the denominator. If that's the case, probably the easiest thing I could tell you to do would be to try and cancel these fractions out, because I can cancel these numbers out. So think for me for a second, something that both 2 and 3 would divide into. 6, you could use 12, there's a lot of different options. If you can think of a smaller number, it makes it easier to work with. Okay, if you can think of that number, I'm going to multiply everybody by 6. Okay, now I'm going to write this out. You guys can kind of skip this step if you want to, but what would happen on it would be in the top of each of these fractions. So I would multiply by 6, and if I've picked a number that both of those denominators go into, it should just cancel out the fraction. Now, the one thing people will forget to do on a question like this, you got to take the 3 times the 6 also. So like this would become 18 over here. Now, what I'm going to do, I'm just going to, just using reducing here, like 6 divided by 2, this would be 3. You still have to multiply it by that x plus 3. So I'm going to leave that in parentheses for a second. Here, 6 divided by 3 is 2. It would still be subtraction in between. But that way I just totally eliminated the fraction. And we got to do a little distributive property here, but it's not too bad to do. So I'm going to get 3x plus 9. Now, in the middle here, since we were subtracting, I would just distribute that like a -2. So this would be -2x. -2 times -20 is going to become positive 40. And we're just going to go from there. On this side, if you just combine your like terms real quick, you're just going to get a plain x, because you have 3 minus 2. And then for the plain numbers, I have a 9 and a 40. So we have 49 equal 18. So then I just have to do 18 minus 49, whatever that is. And I got -31. Now, on this question, you never have a variable in the denominator. So you would not have to worry about any kind of an answer being extraneous or anything like that, because whatever you get, you're never plugging it into a denominator, so you can't divide by 0. Does anybody have a question? Okay, I'm just going to try a couple more of these. What would you tell me would be a common denominator between 5x, 3x, and 3. 15x. Okay, so what would I need to multiply the first fraction by? 3. What about the second fraction? 5. And what about the third fraction? 5 and x. Okay. Now, I'm just not working on the bottom. All of those would become 15x if we actually simplified them. I'm just not messing around with it. We're just going to work on the top. If the denominators all match and you're adding or subtracting, we're subtracting here, it forces the numerators to be equal. All right, so 3 times 3, don't put 6, should be 9. 4 times 5 is 20. So it's literally just 9 minus 20, so just numbers here, equals 5x. So this would be negative 11 equals 5x. Not a nice number here. I'm going to divide both sides by 5. And I'm just going to, this fraction doesn't reduce. I'm just going to leave it as negative 11/5 is my answer. And as long as it's not 0, 0 would be the only thing that would cause you an issue in that lovely equation. Okay, now, this one. People mess this up because they just think they can add a 1. You can't do that. So let me do one thing really quick first here. I'm going to just space this out just a tiny bit. And I'm going to write on the other side, I'm going to write 1 over 1. Okay, now, I don't know why people do this. They're tempted. You have to multiply top and bottom by the same thing. So if this has an x, you can't just add 1 to the top and bottom to make it match this. It doesn't work that way. So this has an x, this has an x plus 1, this doesn't have anything but a 1. So your common denominator here is going to be x times x plus 1. So this one would need an x plus 1. This one would need an x. And then this one would need both, x times x plus 1, x times x plus 1. All right, now, once you have that, again, I'm not messing around with the denominators. All the denominators would be x times x plus 1. You don't need to, like, actually distribute or anything. Just going to cross it out. Just work on the top. Now, the first one, I'm going to have to distribute a 4. So we're going to have 4x plus 4. In between here, this is subtraction, and just 3 times x is just 3x. And then on the other side, you would want to actually distribute the x, because we're going to have to solve this. This is going to end up being a quadratic, because I'm going to get x times x, so we're going to get x squared. And then x times 1 is x. Now, totally up to you, but you want to set this equal to 0. I would recommend, like this side here, let me just do it real quick. This would be x plus 4 on this side. X squared plus x. What I would recommend, especially if you want to try and factor, which I'll make all these factorable, which is not going to be an issue in this particular question, but I would keep the x squared term positive. So to do that, I'm going to actually, I'm just going to do both of these in the same step. I'm going to subtract x, and I'm going to subtract 4. All right, now, I'm just going to get here, x squared. The x's actually cancel here. And minus 4. Now, there's 2 ways you could do this. You could actually just solve this. Like I was thinking we were going to have a quadratic, we might have to factor, but you could just add the 4 back over to the other side, take the square root, or if you guys remember, this is a difference of squares, so the factored form of that, x minus 2, x plus 2, either one of those will give you the same answer. If you added the 4 back to the other side, took the square root, you'd have plus and minus 2. I'm going to get plus and minus 2 if I do it in factored form. So either way would work there. Neither of those cause you a problem. Numbers that we would not want to get as our answer there would be 0 and negative 1. Does anybody have a question? Okay. Now, this first one on the back has like no space, and you're like, what the heck? But do you guys notice that in this problem right here, the denominators actually already match, right? They have the same denominator. So this is very similar to the ones we did on the front. If the denominators match, which they already do, then all I would do here is just work on the numerator. So it would just say y minus 2 equals 4. All I would have to do is add 2, so y would be 6. Now, another way, like the reason I'm telling you, if the denominators match, it forces the numerators to be equal. This would be an excellent example. If you wanted to solve this like a normal proportion, you could do that too. But if you did that, you'd have to FOIL, like y minus 2 times y minus 6, 4 times this, and it would end up being a quadratic. Whereas if I notice this, these match, just cross it right out, and that's my answer, and I'm done. Am I going to stop there? What's wrong with this? Yes, this is the one answer I could not have, because if I plug that in for y, it makes the denominator 0. So in this case, this would be like an extraneous solution. So that doesn't work in the original problem because it causes you to divide by 0. If that's my only answer and it doesn't work, then this one doesn't have a solution. So just check real quick before you write your answer. Does anybody have a question? Okay, now I put this next one on just because I think people have a rough time trying to figure out what do I do with this negative, right? Because this has a little negative out in front of this fraction here. So it's totally up to you, but you either attach the negative to the top of the fraction or the bottom of the fraction, not both. If you've got two terms in like the denominator here, like I do, and just one in the top, the easiest thing I could tell you to, and I just usually attach it to the top anyway, but I would think about this as negative 3a over the a plus 15. Because if you put it in the top and the bottom, really then you're multiplying top and bottom by negative 1, which is not just a negative sign, because then I'm canceling it out. So just attach that negative either to the top or bottom. And then this one's a little weird. So to make a common denominator here, or you could just cross multiply like a normal proportion, it's the same work that you would do. You would have to have an a plus 15 on this right side, and you would have to have an a minus 9 on this left side. So if I create the common denominator, it would literally be the same action as doing like your cross multiply divide with a proportion. It would be the same thing. Same amount of work. This guy's going to result in a quadratic that's a little bit tricky. So I'm just operating on the numerator here. On this side, you'd have to distribute that negative 3a. So I'd have negative 3a squared plus 27a. And then on the other side, I've got to distribute the 3. So I'm going to have 3a plus 45. Now, what I would tell you, if you do end up with a quadratic, we're going to set it equal to 0, but try to keep your squared term positive. In this case, the easiest way to do that would be for me to add this 3a squared, and I'm going to subtract 27a. I'm just going to do that in the same step. Now, if I do that to the other side, there's nothing for me to combine the 3a squared with. So I'm just going to come over here. We're going to have 3a squared. Now, I have 3 a's right now. Minus 27 would be negative 24a. And then we had just that 45. There was no plain number. I moved to the other side. What do you guys notice about all the terms in that equation? Divisible by 3, right? So let's get rid of it. Totally legal to do this, because you can always divide 0 by a number. You just can't divide a number into 0 pieces. So this will stay 0. This will become a squared minus, what is that, 8. And 45 divided by 3 is 15. Okay, can you think of two numbers, multiply to get 15, but add to get negative 8? Yes, ma'am. Negative 3, negative 5. Now, our actual answers then would be positive 3 and positive 5. And then just real quick check, the only two numbers that would have caused you, I'm off the screen here, let me pull this back down a little bit. The only two numbers that would cause you problem in that original equation would be if we had gotten negative 15 or positive 9, which we did not, so both of those answers work. Okay, does anybody have a question? Now, if you get one like this, I can't do anything to that first fraction, but that second fraction I can actually factor. And this would be another situation that I would tell you this will make it easier to get a common denominator between the two fractions. Otherwise, we'd have to have a quadratic. If I just get a common denominator, we will not have a quadratic to solve. Because this guy on the bottom here, this is a difference of squares. X squared minus 9 can factor into x plus 3, x minus 3. And if you notice, on the other side, I have an x minus 3 already. It didn't really look like that initially when I looked at the problem. To create a common denominator here, all I'm missing on this side is the x plus 3. So now, if I just do that, and I just have to do it to that one side, that makes those denominators match, and that saves me from having to work with the quadratic, because I can just work with that numerator there. So the top of this fraction, if you distribute 1, it's not going to change anything. We would literally just have x plus 3, and then the other side would just be the 6x. And all we'd have to do is subtract x. This one doesn't have a nice answer here. So I'd get 3 equals 5x, divide by 5, and our answer is going to be 3/5. And that would not cause you a problem in the denominator. Only things that would cause me a problem would be if we were to get 3 or negative 3 as our answer. Then it's not what we got, so we're good. Does anybody have a question? Like I said, you can also solve this using a quadratic. Like you could cross multiply, divide. It would just be a lot more work, and I'm trying to save you the time. And the other answer you would get if you use the quadratic is either going to be 3 or negative 3, so it would have been extraneous. Okay, let's do one more. This one's a little weird too. Just tried to do every type for you guys today. All right, so I'm going to leave this first fraction just alone. It's already in factored form for you in the bottom there, so just leave it that way. Now, in the middle here, I have just plus 2, so I'm going to convert that to a fraction just by writing it over 1. And then on the other side, I have 5a over a plus 8. What would a common denominator be between all three of those? It's just the denominator of the first one, right? Okay, so here's all you're going to do. And I would just leave it in factored form for the moment. So I do 3 times a plus 8, because we need both parts of that denominator. All you would need here on the last one would be a 3. Okay, now all my denominators are the same, so I'm not even going to mess around with that. The first one, I already had the common denominator, so it's just going to stay 6. How would you simplify this 2 and then 3a plus 8? Like, how would I simplify that? Exactly. Just multiply it. Like this would just be 6. 2 times 3 is 6. And then just distribute that as a 6. You do have to distribute that. The other side, you just have 5a times 3, so that would be 15a. But this is going to avoid us having a quadratic. So this will be 6 plus 6a plus 48. So make 15a. And I'm going to kind of do, oh my gosh, I'm at the bottom of the paper. I have no space. All right, so let me do 2 steps in one. I'm going to subtract 6a to the other side, and I'm going to add the 6 and 48. They're both on that left side together, so we're going to get 54, and 9 minus 6 is going to be, or sorry, 15 minus 6 is 9, and this actually ends up being a nice answer. I'm going to divide, but you cannot see what I'm doing on my paper. I'm dividing both sides by 9. What's a going to be here? 6, right? 54 divided by 9 is 6. Not going to cause you a problem. I never have anything that would be 6 causing the denominator to be 0. Okay.